Good day guys, welcome to another Math Olympiad class. Today we shall continue from where we stopped last time. So today the last question I sent as an exercise is 32 raised to power 5 x minus 3 equals 1. So we have to find the value of x. Now if you remember, I said any 10 raised to power 0 is 1. So in order to have the same base, we break down 32 to 2 raised to power 5. Then it will multiply the power there before 5x minus 3 equals, to get 1 we can just say 2 raised to power 0. It will still give us 1, so that they have the same base. So the base cancels the base, so we have 5 into bracket 5x minus 3 close bracket equals 0. So if we open the bracket or expand the bracket, we have 5 times 5x 25x minus 5 times 3 15 equals 0. So if you add 15 to both sides, we have 25x equals 15. That one now give us, if you divide both sides by the coefficient of x, which is 25, we have 25x over 25 equals 15 over 25. So 25 cancels 25. We have x equals 15 over 25. That means x equals 3 over 5. That is 5 in 15 is 3. 5 in 25 is 5. Question number 2. We have 3 raised to power x minus 2 raised to power x equals 65. Find x. Since x multiplied by 1 will give us x, we can as well replace 1 by 2 over 2. 2 over 2 will also give us 1, which is still 1. So we want to multiply x as the power on 3 and 2 by 2 over 2, which is also 1, which will still give us 3 raised to power x and 2 raised to power x. So this we want to do in order to be able to make sure they have square, so that we can make use of difference of 2 squared. That's why we are using this method. So that means we have 3 raised to power x multiplied by 2 over 2 minus 2 raised to power x multiplied by 2 over 2 equals 65. So if we multiply that to get 3 raised to power 2x over 2, which we can equally bring the 2 out to be square, which will still give us 3 raised to power 2x over 2. So it's the same thing as 3 raised to power x over 2, then everything square, minus 2 raised to power x over 2, everything squared equals 65. So all we just do is to represent our 3 raised to power x over 2 as p and 2 raised to power x over 2 as q. So we have p squared minus q squared equals 65. So we use difference of 2 square here. We have p minus q, p plus q equals 65. So the two factors of 65 are 13 and 5. Now we give 13 to p plus q because p plus q is greater than p minus q. So p plus q equals 13 equals to 1 and p minus q equals 5 equals to 2. Now we have two equations here, p plus q equals 13 and p minus q equals 5. If you add the two equations together, we have p plus p equals 2p and 13 plus 5 equals 18. Plus q plus minus q will give us 0, that will eliminate. So we have 2p equals 18. So if we divide both sides by the coefficient of p, which is 2, so we have 2p over 2 equals 18 over 2. So 2 cancels 2. 18 divided by 2 is 9. So we have p equals 9. And if we substitute for p as 9 in any of the equation, let's say equation 1, we have 9 plus q equals 13. Then q equals 13 minus 9. Q equals 4. Now, if you take the second part of it, that's 3 raised to power x over 2 equals 9. Then we now have 3 raised to power x over 2 equals 3 raised to power 2, because since our p equals 3 raised to power x over 2 and p is as well equals to 9, so we can just equate 3 raised to power x over 2 equals 9. Then we can break down 9 to 3 raised to power 2 so that they have the same base. So if you cancel the base, we have x over 2 equals 2. If you cross multiply, we have x equals 4. Now if you take the second part of the equation, we have 2 raised to power x over 2 equals q. And our q is 4. So if we plug in q as 4, we have 2 raised to power x over 2 equals 4. Then we break down 4 to be 2 raised to power 2. Then we have the base to be equal, and we cancel each other. So we have x over 2 equals 2 over 1. So we can cross multiply, and then have x times 1 equals 2 times 2. Then we have x equals 4 as well. So we have this question as our exercise. 3 raised to power y minus 2 raised to power y equals 8. Find x. We shall discuss that in our next class. Thank you for listening and watching. And then don't forget to click the subscription notification and like button.